start of this school year. I'm going to turn it over to Albert and Judith from Innovamat in 2 seconds. Well, we sent a message yesterday and the day before that if anybody would prefer to have the version of this presentation done in Spanish, we're running a separate room where we have another presenter from Innovamat who will present this entire event in Spanish if you prefer to hear it out rather than being here with us. If not, there's cookies, there's juice, there's water in the back. Help yourself if you feel like you need to have a little snack. Please just put it in the garbage can when you're done with it. Again, thanks for coming. I think it's really, really important. And oh, thank you. The bathrooms, so really important. If you need to use the bathroom, go out the gym, make a left and go up the stairs. There's boys and girls room right at the top of the stairs. Okay? All right, thanks again for coming. Enjoy your evening.
Thank you. Okay. So my name is Albert, and we are conducting a family night. It's almost night-ish, so I feel comfortable with this name. It's a little bit early for Spanish standards, but we can call it a night, okay? So, we are in Innovamat, and I'm gonna introduce myself first, that's the polite thing to do, and then we jump into what is Innovamat. We'll do some activities around our philosophy, and hands-on activities, so you'll be thinking, and you'll be helping your parents. I see many students here, right? And then after that, we will briefly talk about the names in the program, right? So what is adventure? What is number lab? All those words that we are hearing from the students. Are we ready? You can, since it's not such a big group, and I am used to be like in a classroom, let's just raise your hands if you have any concerns, but I will try to devote 10 minutes at the end to address your specific questions, and we are happy to stay a little bit later, just to go one-to-one if you have some questions. Okay? Nice, so that is me, and I wanted to start with just 5 fast facts about me. First one, my accent is funny because I am from Barcelona in Spain, and as you can see, so is my barber. I don't trust any American barbers yet, but I'm going back in a month, so that should be okay. From Barcelona. Second, originally I was an engineer, but 10 years ago I became a math teacher, high school math teacher at the beginning. I started seeing that education was my passion, and then a couple of years later, I became a professor at the university back in Barcelona. I am teaching math to pre-service teachers. So that's what the last 8 years of my life have been. I am devoting all my career to math education in pre-service teachers, so in elementary. Okay, so visiting lots of schools, doing lots of classes in elementary and in middle school, and also doing, as a researcher at the university, my PhD in elementary and middle school education. Okay, so even my background 10 years ago was high school. I am now more into elementary and middle school. And that's the fourth fact. And I also am here. Part of my job is at the university, and part of my job is at Innovamat. And we are bringing this program to the US, as you know now, because you're doing, or your kids are doing it, here in Berlin. Okay, now 5 facts. Is that 5? 4 facts about Innovamat as an organization. We are in 2,000-something schools, right? So 2,100, more or less. Almost 20,000 teachers use our program every day. Almost half a million students all over the world. And 9 countries, mainly in Spain 5-6 years ago we started. Now Italy, Mexico, Colombia, Chile, Ecuador, Brazil, Peru, and the reason why we are here, the United States. Okay? So that is a little bit of an overview, and I will go deeply into the content afterwards. But as I was telling you, the schedule for today, a little bit of our shared vision on math education. Why did I add the word shared? Because that's not Innovamat's vision. It's not that we fell over a tree and thought, oh, that's the way math should be taught. No. That is the way research books, mostly from the US, have been saying us how to teach math for the past 30 years. some things were changed back in the days, some things are starting to change slowly. And this is our shared vision, not just in Innovamat, but with the math community. This afternoon, well, this night, we're driving to Washington, D.C. to a conference. The National Council of Teachers of Maths in the US and Canada is hosting the annual meeting there. We have a couple of presentations, Judith there for kindergarten and myself for elementary. So we were invited there to participate as part of the conference. And we are learning every day from the experts and what's going on and from the experiences that we have in the class. Okay? After that, we will be doing some key traits of our program, just for you to know 4 or 5 concepts from the core program, and then opening to questions. But as I was saying, please, if you have any question, it's not a big group, so we can just stop me and we discuss. Okay, let's start. Are we ready?
Yes.
Good. So, our shared vision, and we start with an activity. I want you to look at the screen and think which one does not belong. Yeah, the kids are faster. Okay, go ahead. 34. 34 is the one that doesn't belong. So now, if save your reason, because I'm asking in a second. But before that, now I could just jump and say, okay, we found it, let's move on. What will happen in the class? Kids will say, no. And within that no, there's critical thinking. It's, hey, wait. We have more reasons, we have more answers. Can you share with us what's your reason behind that?
The 4 is backwards.
Oh, so it's because it's backwards. So if we are looking, if our criteria to decide which one does not belong is being written backwards or not, do we agree with our friend there that 43 is the one that does not belong?
Yes.
Is that a valid argument that we are validating as a class?
Yes.
Yeah. Are we done? Did we find them all? No, let's keep thinking. More reasons. I want to hear you. Go ahead.
16 is only even one.
Oh, so now, and this always happens in a rich class. Go ahead.
Never mind. I was reading that as 43.
Oh, if it's a 34, then no. But if it's written, then we have the conversation. And it's that is the purpose, of course. But considering that's a 43, then 16 is the only what?
Even number.
Okay, that opens the door as we are discussing, and this is just a warm-up, but we are discussing now what is even or odd. If the class knows, we can move on. Everybody here, most of us, know what's even or odd. Maybe some friends here do not know yet what's even or odd. If that was the case, I would be providing you some snap cubes and asking you to make 2 equal groups. Can you make 2 equal groups? That's even. You cannot? That's odd. And that's the definition of even and odd numbers that comes even in kindergarten, can be done. You don't need to know the concept of even and odd, you just need to know symmetry and comparing to groups, right? But let's assume that we know that that's the only, or that what is even and what is odd. Do we agree with her? That is the only one that is even? So if the criteria we are using is even or odd, 16 is the intruder, is the one that does not belong. Okay, good. We have 43, 16. Now my inner mathematician is asking me like a little voice, you have to find arguments for the other 2. If not, I could not say it.
9 is the only single digit number.
Oh, so amount of digits. And now we're opening the door to place value. If that was my goal today, that would be wonderful. Because then we can devote time to discuss, okay, 1 digit, 2 digits. What does the second digit stand for when we have more than 1 digit? That opens the door to place value.
That which really doesn't belong because all the others are second power numbers. 9 is 3, the second power, 16 is 4 times 4.
Now we are opening the door to square numbers.
Square numbers.
No, it's a thing. It's a thing. But I understood.
Yeah.
So there was some math communication in here.
Yeah.
That's the, and then I revoice as a teacher. I say that's a square numbers, and now she remembers. Oh, it's a square numbers. It makes sense. But it was your idea. Powers, right? So 16 is 4 times 4. 9 is 3 times 3. 25 is 5 times 5. 43 is not a square number. What does square mean? It's because of the number 2, the power of 2. But also, if we wanted to arrange a rectangle, could we make a square of 16 tiles? Could we? The pen here. Is that a square? 16. Is that a square? 9. 25, I'm too lazy, but you get the idea, right? 43. No. What's the closest square number to 43? That's a tricky question. 36 or 49, which is the next one. And that opens the door to talk about square roots, eventually. And that's not typically a content in third and fourth. But it's founding it. It's planting seeds that we will gather later on. Okay? Any other reason to exclude any of these numbers? The same little mathematician voice is asking me to find an argument for 25. Because that's the only one that we didn't say anything about. Again, good idea.
16, because it's the only one with no color on the inside. All the rest of the 25 has stripes.
So now, we are talking about here, thank you, that is a good one. We're talking about low floor, high ceiling activities. Low floor, we can start thinking, even if we don't know, even if we could not read the numbers, we could start thinking about the colors, and those properties are interesting from a mathematical perspective because we are now fostering conversation. And then of course we can go to even numbers, prime numbers, whatever you want. That's high ceiling. We can go there and explore within the same activity, but all being part of the same conversation. Very good, you open the door to colors, and that gives me a good idea to discard 25 is the only one with stripes. Right? Let me ask you this, and that is the last argument, and we move on. What if I am only giving you the idea, and then you tell me the one that does not belong. What if we add the digits? What happens? 9 is the only one that if you add the digits, it's not 7. So that could open the door to talk about addition. Those activities are just 10-minute warm-up, but it really gives me a picture of the class. What do you know? What do you don't know? From the arguments that you put on the table, kind of have a very good picture for the class. Okay? Now, if you find any other argument, please contact the school, and the school will contact us with the argument. Because I really enjoy adding more and more arguments here. Okay. Now, just 3, and it's really hard to just summarize all our ideas and research in just some sentences. We do what we could we did what we could in 1 hour. But I wanted to share with you 3 ideas that we stand for and 3 ideas that we avoid. We stand by conceptual understanding. That means we really dedicate lots of efforts into ground conceptual understanding. We don't want our students to just memorize and go on. We want them to really understand. And that takes time. It's faster if I say, hey kids, these are timetables. Just read them, memorize them, good night. 2 minutes. Of course, if I want to build conceptual understanding of what is a timetable, that will need some hours. Really, with manipulators, drawing, discussing. But it's a good investment. Because as a high school teacher now, I speak to you. Many kids arrive to high school and they seem that they don't really know the facts. They don't know how to add, they don't know how to subtract, they don't know the timetables. It's not that they didn't do that in school, it's that they forget. Why they forget? Because they cannot remember. Why they cannot remember? Because they didn't understand. What if I ask you to go backwards from Z to the beginning of the alphabet? Would that be easy or hard?
Hard.
Hard. Why? Because the alphabet has no reason behind. The alphabet is just arbitrary. Either you know it or you don't. If you know it, going backwards is really hard. Now, if I ask you to go backwards from 1,002,036, maybe you never went that far, but you could come backwards from there. Why? Because you really understand place values and numbers. And numbers make sense. The alphabet is just a memorization thing. So that difficulty that you are experiencing, if I ask you just fast, move on from letter T, what's the next one? And you have to go to the beginning, that's my case, like a T, wait. That is what kids are doing when they are not getting, and they are counting with their fingers. They are relying on memory. Of course that's good at the beginning, but we want to move from there. And again, it takes time, but it's a good investment, okay? And eventually, you will see the fruits. On the opposite, we avoid memorization. It's not a, and I get this question many times in parents' nights, and even with my conservative students in the university. Hey Albert, are you against memorizing the tables? Are you against memorizing? No, I am not. Memory is good. Memory is important. What I am against, or we are against, is starting with memorization. Memorization has to come after we understood, not before we understood. Because then, when you go to algebra, when you change numbers for letters, everything falls apart if you only were relying on memorization. If I ask you now to divide 3x squared plus 3x minus 5 divided by x to the third, would that be a problem? Probably, for most of us. If that's not part of his job, if it's part of your job, obviously not. Why? It's just dividing. What happened? Yeah, that you built the algorithm for division upon memory, and when I change the ingredients, you cannot follow the steps. And that is a problem. That is a problem that we are trying to avoid. Again, I am not trying to sell any magic. This is not a magic formula. This won't change. Like, whoa, suddenly everyone is getting everything and our kids all will be engineers, astronauts. It's not that. It's that things could be done in a more foundational way, and we are trying to go through that with the teachers, okay? We are standing by processes and practices. That's 24 years ago, the NCTM, again, the National Council of Teachers of Maths in the US, said, hey, it's not enough to talk only about content, you should be talking about also processes. And I will go back to there on the next slide, so I skipped that one. We avoid procedures before understanding, which is really close to memorization. And then we stand by differentiated instruction, so like with which one doesn't belong? I ask you a question, but all of you, no matter your level, your math background, could start thinking, right? That's a differentiated activity. It attempts differentiation by itself. And then management from my managing skills or the teacher skills are also important. And we also avoid closed units, and I'll go back to that in a second. Okay, moving on. We'll see some examples in a second. Okay. Now here in this slide, I really love this slide. On our left hand, we have the content. So does anybody here speak Greek, for instance? If you do, I change the language, because I need the language that you don't speak. Is Greek okay? We don't speak Greek? Now imagine that you had a superpower, and I gave you the dictionary, translation, Greek to English, or English to Greek. And you had the superpower and you could memorize all the translations. Would you speak Greek? Well, you would know something more than we know that now, but is that enough? No. We need how to form sentences. We need a literature to enjoy what we're doing, to read, to really understand the language. That is what math was when we were at school. We were just going for numbers, geometry, statistics. Those are the words of mathematics. Those are important contents. But it is not enough. And this is not our idea. If you read books from the 60s, many good educators, mathematicians back in Europe, in the US, Latin America, Asia, which they are great, they're saying, hey guys, content is important, but it is not enough. We need also these processes that make content relevant for us to understand what we're doing, okay? So it doesn't matter that we're doing numbers, geometry, statistics, measurement, data, algebra. How we do it? Through problem solving, real life world problems, open-ended questions, reasoning. Why is this? Today I had the chance to model, and I had all day at this school and other schools of the district teaching in front of the teachers and discussing. And it was one of the things that they say, hey, you're doing a lot, it's asking why. Even when a kid said, yeah, 7 times 10 is 70. And I said, why? Why? Why 7 times 10 is 70? Because I know. Well, why do you know? And then asking why, it's reasoning. He was like, because I can skip count. That is a good idea. Let's share. For that kid it was obvious, but the kid next to him might learn from that experience and from that strategy. So reasoning. Always questioning why. Establishing connections. Math is connecting everything. Did you see how I connected squares with powers? Some kids don't get the numbers at the beginning, but they get the geometry behind it. So if you do the connection with geometry, you are adding some students that might be lost to the party. Okay? And else also, and that is very important, and these days, as a teacher, I would say one of my main concerns is communication and representation. Kids these days are not very good reading and understanding what they read. They are not used to read as we were in the past. They have many screens, many inputs, and it's a little bit hard. So it's important that within the math class, we also target reading skills to understand word problems. What are they asking to do? And that's not even new. I probably assume that you were a little bit familiar with these words. It's about putting them together in a curriculum, in a program that makes sense and that covers the standards and prepares the kids, making sense of these processes. Okay, does it make sense? Actually, when you read the standard, when you read the law of New Jersey standards, they devote half of the document to the right part. It's just that, of course, we are more concerned with the content. I agree, and I can understand why. But don't lose the perspective on making sense of things, right? Good. Now, the content, I added this idea here, building conceptual understanding. Conceptual understanding sounds like a big word, but it's just making sense of what you're doing. And fluency. Fluency means I want my kids to just say by heart 7 times 7 fast, but not the first day I presented the tables. Once they practice, once they understood. Later, so slower, yes, but for a good reason. So fluency is also a component. And you see that I draw a little spiral there? That's a big thing. So in our program, we are not doing units. Now let me do this exercise with you. Have you ever, now we have to confess. I'm sorry that I'm asking you this, but we are a family now, so we are confessing to each other. Have you ever went to Netflix and watched Netflix or whatever streaming platform you're using, and watched several episodes in one afternoon, like COVID times, like, oh, again, next. They put it so easy. What's the next one? You cannot even say no. You go through all the episodes in one afternoon. It feels good. It feels that you enjoyed the show. 2 weeks later, you go to the next season. You have to go on YouTube. Resume and summary of the last season of Game of Thrones. I cannot remember what happened. Because I watched it in one afternoon or even in 2 days. Everything, I ate everything fast. And then it fades away. It's not the same, but if I was watching one chapter today, I wait, like in the old times. Remember when we had one chapter today, we had to wait 1 week, 2 weeks. That chapter made sense. We could connect that chapter with other ideas. We were reading a book and we were connecting that book with the chapter that we had the time to discuss. We went to the office. This was the last episode, and we had time to discuss about that episode. And that was digesting the content of that episode. We were making sense of it. We were having conversations. We were engaged to that episode. And then 1 week later, 2 weeks later, we watched the next one, and it makes more sense. And we didn't never had to re-watch a summary of any season. We really understood what was going on. We kind of distinguished what happened at the beginning of the season, what happened at the end of the season, because we had the time. What we are saying with the spiral is that we don't use units. Unit 1, addition. Doing a lot of addition for 5 weeks, and then we move on. Subtraction. And my kids were asking me with units, Albert, but how are you asking us an addition today if addition was last unit? That's not how math works. Math is building upon and connecting ideas. So instead of doing 5 weeks of addition, 5 weeks of subtraction, 5 weeks of fraction, then summer comes, and in September the kids seem brand new. They seem that they never went to school. Because addition is 8 months ago. The other way around, we do session 1, addition. Session 2, maybe subtraction upon addition, connecting ideas. Session 3, maybe we introduce a new idea about geometry, triangles. And we connect the times 3 table with the triangle that we are learning. And some kids are getting the times 3, counting vertices on a triangle, which fosters a connection. Unit 4, we go back to addition. Unit 5, we do a little bit more of subtraction. Unit 6, we introduce fractions. Unit 7, we go again through triangles, but extended to squares. You see what we're doing? Like going one unit. It's like going slower. Not doing full units, but going in what we call, and it's not our idea, it's not the Innovamat idea, it's a research-based idea, spiral of learning, spiral trajectory. So we go through the content once, and once again, and once again, and your kid at the end will be doing 10, 15 weeks of multiplication, but not all together, split it in the year, connected to many other content. And that, at the beginning, feels a little bit uncomfortable. I'm giving you that, yes. Because we are used to, no, we have to master addition before moving on. That's not how our brain works. Slower, but safe. That's our approach with the spiral. And then, let's see an example of a spiral, of what I am saying. This is the spiral, just a few pictures, and Judith can identify here. A couple of them are from elementary, from kindergarten. The two on the left are kindergarten. What do you think is this about? Well, it's on the title, I suppose it, I'm sorry. Symmetry, right? So can you see at the beginning, the first picture, kids are experiencing with paintings. They fold the paper, they unfold, and they can see the symmetry, like the butterfly. They are connecting those butterflies with some pictures. Second, it's 1 year later, or at the end of K. We can see with the mirror and some shapes. We go again through symmetry. When kids are a little bit older, they can understand what's going on with the mirror. Then first grade, we are drawing symmetry, which is a little bit harder than just representing with our hands. And then, what do you see on the right? That's symmetry, yes, but also, what's that? It's three-dimensional, I agree. What else can you see there? How many cubes? 3, and then 3 on the mirror, right? So that's 6. I agree. 6. Almost 4, close enough. So it's 3 and 3 more. Through symmetry, I am connecting 2 doubles. I am connecting 2 times 2. So I am opening the door to tables. Albert, some teachers ask me, Albert, why are we doing symmetry and mirrors that early? Because the day we are arriving through the spiral, if it's well designed, when we arrive to doubles and when we arrive to, in this case, times 2, it makes more sense. Some kids, don't get me wrong, the kids that were doing great with old math, they do great with this. But some of the kids that were not getting abstract ideas like doubles out of nowhere, this is making more sense. And it's more based on their previous experiences through that spiral. And it's not a flat spiral. Actually, it's like a staircase. It's going up. So we go again and again through the same content, but harder. More deeper, sorry. Another, and that is more relevant to you guys, this is multiplication. The spiral of multiplication. And now, kids, close your eyes, this is a spoiler of what's coming. Okay, first, what is multiplication? Multiplication relies on repeated addition. So, on the left, what's that multiplication? 4 times 6. It's actually, yes, it's the same result, but it's not exactly the same. 6 times 4. Do you agree? If I don't know how to multiply, can I add the dots? I did a session on this today. Can I add the dots? Can I go to a previous knowledge I can to start building upon? Yes, I can say 1, 2, 3, go through it, and then figure out the result without needing multiplication. And I am opening the door to multiply, which is more efficient in this case. That's not the only approach to multiplication, because multiplication is not just adding repeatedly, but also counting rows and columns. For instance, if now I wanted to know how many chairs, would you count one by one? No, you would count rows and columns and multiply. That's the second biggest idea behind multiplication, the rectangular model. So there you have an array. That's the array or area model. And again, if the kid is not able to yet know the multiplication, you can rely on counting, adding, just counting the squares there. And that is 3 times 8 that should be drawn inside that grid. Okay? But this spiral goes on. And this is first weeks of the second term in 3rd grade. We are doing the times 3, okay? With triangles. Don't get me wrong, this is just a picture of the final part of the session. We are doing lots of hands-on manipulatives. Today we didn't have the time to do that. But this is the last part. So can you see? I think it's small, but first sentence says 4 triangles have vertices. Some of them are hidden behind other triangles for them to count. You can count some of them, but some of them you have to imagine. So we are scaffolding our way to abstraction. Maths are abstract. Math is an abstract science. But you can reduce that abstraction through manipulative drawings until you're ready. Okay? And then I love on the right, there is this times. I don't think that we can see it, but just let's draw the first one. This is like an abacus and tens and ones. 1 times 3. 3. So we are doing 3 ones, okay? Then the second one is 2 times 3. 6. And the third one is 3 times 3, which is 9. Okay? Now, under the 1 times 3 is 4 times 3, which is 12. And then under the the 2 times 3 is 5 times 3, which is 15. And I'm not continuing, but the goal there, do you see the big rectangle on the left that says what do you spot? We're devoting time to discuss. Reasoning. What's going on here? How many bits did I use here? 3. How many bits did I use here?
3.
We'll start seeing patterns. How many bits do you think we will use in 7 times 3? 3 again. Some kids might not remember the tables just by heart, but they can start seeing those patterns, and that's another ladder another rope they can take when they are lost. It's not magic, it's just giving them many entrances to the same idea. How many bits? 6. How many bits? 6, and then 8 times 3? 24, which is 6 bits. So you start seeing lots of patterns, okay? I love this session about building the tables. But the spiral goes on. You can see on the left the rectangles, how we build the idea of multiplication beyond the times tables. And then on the right, we can see the rule of 0. If you know 2 times 4, can you know 20 times 4? Yeah, you can deduce that from there. So we are devoting time to foster those connections as well and have that conversation in the classroom. Now at this point, some parents ask me, hey Albert, but what about the traditional algorithm? Great, the traditional algorithm makes a lot of sense in a world without calculators. It's not that it doesn't make sense in our world, but we should arrive to the traditional algorithm after we build our ideas. It's the end of the road, it's not the beginning. Because the traditional algorithm has lots of hidden steps that we have to memorize. And that is why now you feel uncomfortable if I ask you to multiply 2 polynomials, x squared plus 3x multiplied by x squared minus 5x. Why you feel uncomfortable multiplying 2 polynomials? Because you followed steps through multiplication. And when I change the ingredients, you kind of, and maybe some of you know how to multiply polynomials if you remember from high school, but typically it's not the case because we are so used to the steps that we follow that make no sense just because we follow, that when we change those in high school, or at the university, eventually somebody's going to change those, everything falls apart. So it's not that we are against the algorithm, it's that we are against of starting with the algorithm. Okay?
So when does the algorithm become part of the process within Innovamat?
What algorithm? For multiplication?
Or anything?
At the end of when they are ready to understand. It depends on if you say the algorithm for addition at mid-second grade or third. If you ask, or beginning of third. If you ask me when does the algorithm for multiplication arrive, that is beginning of end of third grade. Beginning of fourth grade is reinforced, and we go again at mid-fourth grade, the traditional algorithm. Yes.
So you said when they're ready. What if half are ready and half aren't?
Yeah,
Like
then
in a classroom.
that
How do you
happens. Of
differentiate
course,
that?
that happens. At least we provided the opportunities for those who were to go there, and the ones that are not, in my opinion, but that's also a decision from the district, I wouldn't push too much for the algorithm. Because the algorithm is, I mean, are you using the algorithm on your everyday life?
Well, I'm a math teacher, so yes.
But that is a very good question. I could answer. Math teachers, so only math teachers actually, we use the algorithm. In our everyday life, I am always the math guy in my group, so I go to the restaurant and they say, hey, do the math.
Right.
Do I do the math? I have a calculator. So I'm not doing the math. The thing is, algorithm, that means that we don't have to teach the algorithm? No, it's cultural, it's valuable, it's about patterns as well. The problem is starting with the algorithm. So we kind of push it until we grounded the ideas of what is to multiply. What is to multiply? Once we get that idea, and actually the area model is also in the standards, I mean the tests in 4th grade. So this is on the right, you can see the rectangle model, which is the algorithm that actually goes in the standards in New Jersey in 4th grade.
So the ones that aren't ready never get it, is what you're saying?
No, the ones that aren't ready, they will get it, and they will maybe memorize in that case, and eventually when they are older, they will get it, like we used to do. It's not magic, again, it's not magic.
What if we don't use Innovamat next year? Like, and they didn't get it this year?
Then you can teach the algorithm in one day once they understood what's going on with that. It's not that doesn't happen. Typically, I've seen many students that go to high school without my background, and I have to teach the algorithm no matter what. Even the algorithm was taught several times from 3rd, 4th, 5th, 6th, 7th, and I am an 8th grade teacher, and I have to teach the algorithm again. So it's not that we are sacrificing valuable times for anything new. It's that we try to make sense of that. Some kids will get it, some kids don't, and with those kids we have to keep working.
Albert, may I say something?
Yes.
And I see even with the little ones, when you go to the abstract part, then this part, it will be like the algorithm itself, it's more likely that they will understand it because they know where it comes from. Because when it's like magic, if you don't remember how to do it, you cannot figure it out. But if you know what those numbers mean and why are they placed that way and why are we using this algorithm in that way, because they know how it comes from, it's more likely that those students that it takes a little longer to get there, they will get it and they will retain that information. Because they know where it comes from. It's not a magical thing. So everyone will get there just at their own time, but it's not that we don't need to know how to do it. It's just that we will understand why we're going there, how to use it. So it's not that I have to memorize it. I know how to figure it out. If that makes
And
sense.
then I love it. But being a teacher is also making decisions. Making a program is making decisions, being a teacher is making decisions. And the thing is that I can devote, 20 hours to just go through the algorithm too early and practice it again and again and again and again. Or I can devote 15 of those hours to figure out other strategies, have the conversation, see other algorithms, it depends on the culture, they are using different algorithms, they just go fine. So we are seeing many strategies, and then devote the last 5 hours to the algorithm. Some of them will be helped because of that previous work, some of them will need more help. But that's not changing because we are not teaching the algorithm 20 hours in a row. Go ahead.
I now have a couple options with that. So my first question is, how many decisions do teachers get to make and how much of it is scripted?
It's everything scripted if they want to follow, but even myself, I wrote some of the guides, not all of them of course, some of the guides, and when I am teaching, I make decisions depending on the teacher, the student reactions. If the guide says, do this exercise 3 times, but the kids already know it, I do 1 and move on. I mean, it's all about deciding this exercise goes in, this exercise does not go in. It's deciding that. But you can follow steps.
Okay, second one is about the kids who are ready for the algorithm because they have the understanding about it without all this, the concrete, the representational. Do you have an example of what that looks like within your script? And so essentially they have to wait.
Yeah, and that is a good question. I like that question because typically it concerns us. And my first approach, like 10 years ago, before researching and understanding how our brain works with math, I would say, yeah, well, move on with these kids. Like, present them new things. Completely wrong. So you wouldn't rush with the kids. You can really ask them to go for a deeper understanding of this and go for a high ceiling. For instance, today we were discussing about the number line. Do you know the number line? We draw a number line and we jump. Some kids don't need that line to understand addition. Let me do an example. Because that is a good question, I like it. So, today we were in a session that we were doing 346 plus, I don't know, 125, okay? And some kids were able to do this without the numbers. Some kids were able to do this in a vertical algorithm. Some kids were able to do this just in their heads because they know how to add digits and they just go fine with it. And I was like, no, let's go through this jumps, right? So I would jump 100. Where would I land if I jump 100 from 3, 4, 6? Oh, sorry. It's 3, 4, 6. Where would I land? If I jump 100, 4, 4, 6. And then I would jump 20. I could jump 10 and 10 if I needed to, but let's jump 20. What's that? And then I would jump 4. You see why? Because I need to stop there. I am having some trouble, so I need to stop in 470. And then I'm doing one last step into 471. And some kids didn't see the value of that. Some kids were just, hey, why would we do? And some teachers were asking, hey, I wonder the reason behind why we are doing the number line, right? The number line is a model that helps in many things, and now I don't have the time to share, but I am sharing you some of them. One is mental model. Some kids are really better at jumping than just drawing the numbers one after the other one, like one and the other. But that's the least important reason. The most important reason is that one day your kids will discover, cover your ears kids, that 0 was not the first number. That we have numbers, actually infinite numbers before 0. And understanding the number line and jumping in the number line is very useful to understand that you can jump to the left from 0 and negative numbers is a new world for you. If you just did the algorithm, the standard algorithm, understanding negative numbers is really abstract. So working with a number line since kinder, it's not a number line but a beads necklace, it is really fundamental. Also, there is another little lie that we tell kids. After 1, what's the next number after 1? 2? No, I'm sorry, between 1 and 2 there are infinite numbers. How do you understand that if you only come from algorithm abstract ideas? It's about, yes, the number line can get expanded. So before 1 and 2, you can make zoom and actually talk about middle numbers if you win and open the door to talk about decimal numbers. So sometimes we think, okay, our kids are ready, they don't need this, we can move on to the algorithm. We're not just opening the door to strategies just because. We're opening the door to those strategies that are grounding and that are making the foundations for them to understand complex idea later. It's interesting.
I think my concern is just like we're giving glasses to everyone regardless of what their vision is. Like you
It's
20/20 vision.
No,
and
it's not
we're
giving,
giving
I
glasses.
completely disagree. It's not giving glasses, it's about discussing strategies, and it's about fostering the thinking that is not the content. So
Within the
with
script, is there like a enhancement or an upper level thinking? Like, or is it just they're getting back?
This is the end of the session. This is the end of the session. This is 10 minutes at the end. Some pictures and some activities like a work. But the activity comes from a conversation that will explore several branches, and no kid will get bored. That's not typically what happens. No. So they will explore, and it's not, some kids are just completely fine with this, but then we can start discussing with them what happens if, and those questions are in this one. We don't need to go to further content to go to deeper thinking.
So are those questions provided in the script?
Some of them yes, and some of them the teacher just with their experience add them. But yes. I've never seen a kid that is talented in one of our class just say, yeah, this I get it. Sometimes in some specific moments can happen. Yeah, I already get this. Yes, that happens. But overall, with the session and with the thinking behind it, typically it pushes harder than any kid at that age can.
So this is great. I love what you're here in front of us teaching it, right? And the kids go to school, and the teachers there in front of them teaching it. What resources are for the parents who math is not their number one forte? What is the resources that we can get from the website, or is there training, or is there help? Because when you start in kindergarten with this type of math, and you're going to be with it, say, in a district maybe the next 4 years.
Yes, I understand.
What support is there for the parents? Because if the kids can't have the help at home, we're all relying on just one session, and then they have homework, and then there's tiers, and then there's,
That is I can give you like my opinion and my expertise, and then we can discuss the real case, which might be disaligned with what I think. I only give one rule, and Innovamat is not providing, like, this is the homework part. No, we have resources, and if the teacher wants to ask any other curriculum proposal, we are providing resources, and teachers are deciding what is an exam, what is a test, what is a homework, okay? All the research I know are against homework, but that's another thing, okay? We can discuss that outside of this conversation, because I know that homework is an important thing and cultural thing as well. So, the thing is that, with homework, we have only one rule, or from a pedagogical research-based perspective, I only have one rule. Homework cannot be about building new content, building new knowledge. If your kid has to learn new knowledge at home, then you can have a conversation with the teacher and say, hey, something is not working with this kid, he's not getting it, because you are not trained. Teachers have been studying for years, and they have their expertise on how to teach, on how to scaffold, on what questions ask. We as parents do not have that training. I'm not saying that you cannot do it, you could. The thing is that you would need lots of time to learn how to. We are, having said that your kids should come home just to practice what they did at school. Practice, and get better. And of course, within practice, they can have some questions. Of course, that's completely understandable. And then you should have some tools to help. I completely agree. And that is why we have at least these strategies about numbers. You have 2-minute videos in our website. Maybe you saw them. It's about 12 of them, and you can check the strategies. It's 2 minutes with a hands and a voice over there, explaining you how to jump, how to multiply, just a couple of ideas per video, 2 minutes, and that should be like the fundamental part to help them with that. And then the second idea, when I have to help students at home, is asking them, what did you do? And be a learner for a minute. Asking them, what did you do? Sometimes they won't know, and then you might need to ask the teacher, it's okay. But typically they will surprise you. We try to do this, and maybe they didn't get it fully, but if they listened, if they were engaged, they will have some ideas. And from there, with the videos and with the help of the teachers, I think we can work from it. Another question?
I know when I was growing up, I had a lot of problems because my parents were trying to teach me a different way of doing it than what I learned in school. And then my teacher wouldn't accept that. So is this more open to doing
Absolutely
that?
open. Yes. Absolutely open to different ideas. The thing is that if, and that is a very quote, it should be my main tattoo. If you present an algorithm too early, that leads to cognitive passivity. So your brain disconnects. You just follow steps. If I give you a trick on how to do things, you just follow the trick and you forget about thinking. So that is why I would wait and I wouldn't teach the algorithm if the teacher has not taught the algorithm yet. I would wait. How do you do it? Jumping, okay. Or maybe drawing, okay. And when the time comes, the algorithm, okay. After we have several ideas on the case. But not at the beginning. Because if we have a trick at the beginning, we just stop thinking.
Is there going to be something, I know they'll be doing it in school, but is there also going to be something maybe on school issue? Because going back to parents versus students, how are the parents going to be able to help their kids when they do come home and they still don't understand?
Then that is a conversation that you should have with the district. I don't want to jump over what the school decides.
Oh, okay.
Okay?
What happens, you said you get to the end of addition, subtraction, the end of second, beginning of third, and multiplication of third to fourth. What happens when students are not at grade level standard-wise? Because those were the previous year's standards.
What do you mean? Make me an example.
So like New Jersey has standards, addition, subtraction, which happen in second grade. If that's not happening until third grade for some students, how is that?
You mean for some students in the sense that they are not getting it until third grade arrives?
Or in third grade, yeah.
Right.
You said end of second, beginning of third, like master, addition, and subtraction. That's a second grade standard for us. So when they take SID state tests, I mean, that's more multiplication, division, and doing third.
Yeah.
But how does that,
We are completely aligned to the standards of New Jersey. That's what I can say. So we are fully aligned, and we did last year a job of aligning ourselves to the standards, and you will have the test in May, and we can check if what's the disalignment. The thing is that typically things are harder than it looks on paper, right? So we say, yeah, at the end of second grade, all good. That's not happening. It's a rule, it's a standard, it's there, it's golden rule, but when it comes to reality, they always need to know better and to master better. A second grade or a third grader or a fourth grader is not fully mastering anything. Not even addition, not even subtraction. It's just a matter of getting comfortable enough and understanding enough for that age. But they are not master. What is to master addition? To master addition is being able to add anything up to university level. So I wouldn't have that mindset of expecting them to just finish everything they have to learn and move on, because math works really in time. So it's, yeah, we are targeting and practicing enough all the things that the tests are asking you to do, if that's the concern. Yes. Mastering it, that depends on the kid, on everything. I cannot come any kid that will master everything. No. But we are targeting and practicing enough for every year state standards in New Jersey. Yes. And providing tools to the teachers to practice for the test and to practice outside of the test. Yes. And to correct and assess before the test comes. Yes.
so then I guess what happens as the gap gets bigger, as, you know, say, you have a student who's still working on addition and subtraction, and now some of the kids are moving on to multiplication and division.
Oh.
Obviously, in the spiraling
The
sense
spiral,
that
yes,
you said, but as that gap gets bigger through the grades, like what, I understand there's differentiation, but how is that targeted?
Differentiation?
No, like the gap.
The gap, I mean, the spiral really reduces the gap. That's what we know from, not from Innovamat itself, but from research. The spiral tends to reduce the gap. Units tend to expand the gap. That's the best we can do, reduce the gap.
Right, but like, is it possible for a student to be in a grade 1 book or a grade 2 Innovamat workbook to consume a whole product while another kid's in a third or
It's
fourth grade?
theoretically possible. I wouldn't recommend it, and that is a decision from the school.
So then do you just move those kids on to the next book, even if they haven't completed and
There is no
mastered?
fully completed mastery. No, that doesn't exist. It's just being better and better and improving. It's not mastering and closing a door. It's going up a ladder. So it's not closing up.
Do you give assessments at the end of units or at the end of a
We provide the
spiral
tools.
or-
We provide the tools. That's a decision from the Okay, moving on. And I'm sorry that maybe we don't have time for so many questions. Just for you to see the end of the spiral here, like how does it, and that's beyond third, fourth grade, that's, well, it can be the end of fourth, beginning of fifth. Multiplication of fractions. Have you ever thought why multiplication of fractions works? Why 1/5 times, or 3/4 times 1/5 is 3/20, 3/20. We just know because the rule works. Why is that working? Why? Let's focus, and that's the last thing I say about multiplication. Just focus on this example. So we have a square coming from the square multiplication, and we have 1 out of 5 rows. So I go with 5 rows, and I go with 1 out of 5 rows. That's 1 out of 5, 1/5 on this side. And then 3 out of 4, 3/4. I'll go 1, 2, 3/4, and I'll paint 3 columns out of 4 columns. Now, what part is crossed? This one. You can see it better there. So, sorry, it's not good. It's 3/4. So, 1/5 times 3/4 is, out of 20 that we have here, 3. Of course, I can come and say, hey kids, today we're learning by heart the rule of multiplying fractions. This times this times this. And then they get messed when we change the multiplication for addition, and it gets messy when we change it for division, because then the rule goes up and down. You remember that rule? Like going up and down. Why? Why does that work? It makes no sense for many students. They just follow. And then when I change the ingredients, it makes no sense whatsoever. What if we come from a making sense perspective, the rectangular model? It makes more sense. We painted 3 of the 20, 3 of the 20. This is not magic. Some kids won't get it this way either. But it's helping some of them to really understand why is multiplication of fractions working. And this is just an example, but I could go forever with any example. Integer numbers, the derivatives, integration, whatever example you can think of in higher courses can be grounded with actual, real, good understanding. Okay? And I know we're almost out of time, but then the creating a productive struggle is also important. So we are asking our students to keep thinking, and we are very critical with their conceptual understanding. Okay? They will be struggling. That's where learning comes from. Struggle. Thinking. If they know, it's boring. So I have this sentence. If I go into a classroom, I teach something, and everyone understands it first time I explain it, that class wasn't necessary. It wasn't necessary. If everyone understands in 1 hour, I'm not even challenging them. That class could be just away and they will get it. I need to focus on those contents that are between too hard and too easy. That's the step. That's the spot. That's the productive struggle. And how much time do we have? It's almost 7, isn't it?
It's 7.
7. Okay, then I'll skip this example. And I'll go here, which is the final overview of what are your kids talking about when they talk about all these words about Innovamat. So what or how do we build conceptual understanding with our kids? There is 4 hours a week are number lab sessions and adventure sessions. The number lab ones are about number sense. So we are devoting 3 hours a week to understand numbers, which is the biggest part in elementary and middle school. Okay? Number sense, operations, 3 hours a week of that. A lot of conversation, hands-on, but about numbers. Okay? And lots of strategies. Not just the algorithm, but also the algorithm and more strategies. Then, 1 hour a week out of those 4 is adventures. Adventures is more free with a video, a nice video at the beginning with some characters, introducing a context to talk about, and it's more about experimentation, geometry, statistics, probability, all those contents that are not necessarily numbers per se. And what happened in the past with units is that those contents were at the end of the year We didn't have time, we went on vacation, and nobody did statistics. How many of you remember statistics class in elementary? They were in the book, in the textbooks, I promise. They were there because they are in the standards. But they were Unit 9, Unit 10, Unit 11. We went on vacations, those were not done, and we moved on. I don't know if it's the case in your school. I'm talking in general, when you were here. What we are doing with the spiral is that every week, every single week, we have an hour of that, connecting that with numbers. And that makes sense with the numbers. We're just doing statistics with numbers. We are doing geometry using the numbers that we are learning. So fostering the connection between math, not just units and finish. And then, 1 hour a week, we are practicing everything. Because you can build whatever, you can talk whatever, you can discuss, but kids really need some focus time to practice. Several multiplications, several additions. With the algorithm, without the algorithm, with the number line, many strategies, practice. That is done through the app. So they go 45-ish minutes per week to the app on their own, and they practice. And that's, for the teachers, that's useful because they have a report every week to know where the class is, and that is useful for them. And also, the app really adapts to each kid. So every kid would start with the same, but then the app knows where the kid is struggling, and if the kid is struggling with this content, the app is providing a previous content from our map of mathematical content.
The app asks you when you start if you're happy or sad today.
Yes.
Does that affect the level of questions that the student gets?
If the student is sad, the app is a little bit kinder. It's very hard to type, but it's a little bit kinder.
Also, where is that being reported to, and who's checking in on those students who are reporting that they're sad?
No, that is not reported anywhere. If they are sad or not, that is an information that goes in the algorithm, and the algorithm just says, well, if the student is having a bad day, I'm just not pushing that hard. I'm not asking him to go that far away. And if the student is happy, then yeah, maybe I try a different activity at the end, or activity that I know is hard for him at the end. Just try and do it. But that's not information that is shared with anyone. It's just I go ahead.
So realistically, this time frame is not happening though during the school. 1 hour a week on the app is not happening.
Yeah, the beginning, the first weeks, since there is not much to practice, that can be negotiated with the teacher, and maybe the teachers want to devote more time in the training program to the building conceptual understanding and leaving the practice for a little bit later. But eventually, as we roll, it just has been 1 month.
Well, I mean, you could probably check the bell schedule, and it's literally not happening. Like, there is not an hour devoted to math class on one day, especially after they have a quiz on a Friday, and then after.
If they are practicing,
So how is that going
if
to
they are practicing, that's the only purpose of the app is practice. If they are practicing with any other tools, I wouldn't be like really concerned about it, if they are practicing. And as far as I've seen these days observing, they are practicing.
Does that pose a problem though for the spiral that's eventually happening? That instead
If
of
they
an
are
hour,
pra- if they are
20
pra-
minutes, 20 minutes,
If they
20
are
minutes?
practicing, it's okay. The app is built to help teachers not to be checking all the students' additions, like 100 additions per day. That is really hard to do as a teacher. So what teachers did in the past is just not ask so many questions, just reduce the amount of questions you can correct. The app is going everywhere with every kid, so they are getting the information without having to go through every single step. And the level adapts. So every student starts in the same spot, but then as you work through the class, you see different questions going on depending on how the students are performing in that very day. Okay? And that was the important, last important part. And I know we are late and we are done, but if you had any more questions, we have been discussing the biggest concerns at SU, but we will be happy to stay for a while as you go to grab some cookies and some Coke, I don't know what's there. But I'll be happy to stay here around, answering maybe you have private questions, smaller questions you don't want to share with everyone. I'll be happy, myself, Judith will be happy to help you out with any questions that you have. If not, this is very good. Typically, you don't see those many parents in a family night. So I think that you have a strong community, and I think that is good, that you are concerned, you have questions. And sometimes we're debating here, and it looks like we're having a challenge, but I rather prefer that, and you being concerned, than you just say, I don't care about the education of my children. So I really appreciate that you devoted time to this, and let's keep having the conversation. If you have any questions, maybe tomorrow, you'll say, oh, I wanted to ask Albert to reach the school, and they will be happy to share with me. I'm just 1 hour away, and I can come. Okay? Thank you so much for your time. Thank you so much. Any more questions? Yeah. Thank you.
I don't know every school that we do, so I don't know exactly. So yeah, maybe nobody can start because I don't know the way that every school is like more. For the families at home, or for her?
Not at home, like in school.
That's the yeah.
I know like you have any department.
No, that's the thing that we do for school. I don't know if I'm getting it right, like the first year that is like special program. But that's the program we're presenting what they are going to do in school. So this is what they will do because they are changing curriculum. So this is a new curriculum that this school is getting to teach math in the school. So it's for you to understand, like if the kid comes home and say, they number lab or today they whatever, and it's like, what is the kid talking about and why are they going to the school? So this is something that we run as for you to understand what your kid is going to do, be doing in class. They already started. They started this year. So they started like they changed last year the curriculum. They started in September or August. But they already started. So she's learning math. Thank you.
Good night.
I know.
So it's not like the rule like say this, say this, say this. It's like, okay, this session is about transition. Asking them to answer this couple of questions. Probably some kids will say this, maybe you should address this in that sense, so there might be a lot of experience from our previous years from this success, and then we are adapting that as we speak, because we are adapting redoing that.
Can you explain another strategy on that same item? If you did it this way, and another strategy, give me another strategy. That's not more than another algorithm to make the same. That's making sure you truly understand how to go about looking at and that's all. I mean, your language of, like you said, the representation portion of it. Like, color, you don't need to read, which like one day, there's a whole, there's a they're not sharing it. I would put my hand on that they will not be changed by the time I get it. Like that is not. Now I
But you know what, even if he's intentionally where's Mark actually are, he will get a little easier. But he will always get something that is more so it's not that high. It is nice that you but this organization just
So my daughter's in
and they don't do it, they don't do that here, yeah, because they don't do it at the beginning of the year, they start later, and they manage to do
They have a guide to write it out for us, I think, here it is, for the teachers, and then there's a place to
We have.
With the number.
And you can say, so the workshop is the part that we do together as a group.
They can't take it away and they'll do it exactly.
Right.
They
And then the spaces is more like play space. Where they visit all of these other groups, little play, and I was so the teachers have like spoken systems where they all have they have what is the standard that they work first year and they went to the spaces and so they go and senior teachers guys they have standards that
But you know, sometimes you don't get to the logo too, it's like, it's here, and our kids are here, so then
they
we're
were
really
getting for someone to say, yeah, and they had to go like for example, find some numbers and this number they said they were memory, but with numbers and like little markers. Yeah, they had like letters, like they had like red letters, something like that, so they had like we did part. They had anything to do with that, but instead of doing it on a piece of paper, and I saw that so like beautiful conversations like today, one of the they had all the cards full already, and they were all.
It's on the way. It's gotta. I wonder why these sessions are so weird. I just take 2 racks and that's it. I'm assuming Nicole, maybe?
Many other menaces targeting his behavior before a certain end. It's not in a general, I wouldn't say it out, but
I'm still recording.
I would say reaches into 6.
Thank you, thank you.